So here we are. Why don't you go ahead and introduce yourself, and then we'll talk about whatever.
Okay. Well, for anybody who doesn't know, my name is Spencer Crum. Nibblizer on Twitter and pretty much everywhere else where you use some kind of a handle. I'm an engineer for IBM, focused mostly on OpenStack. I guess a little bit earlier, I was focused heavily on Puppet stuff in a lot of different roles. And what I do specifically for OpenStack is I work on their infrastructure team. So every developer commit that goes through OpenStack goes through a pretty hefty CI system, and I maintain and operate that.
So when I first met you, I think was at the configuration management camp.
Yeah, that was a very fond memory, actually. I don't know, everybody went to sessions. That was like you and me and Kelsey and like Gareth.
Yeah.
It's like we're just sitting there, and it was like, oh, this is a pretty cool couch situation.
That was a cool little conference, I think. I mean,
that is really good. They're doing it again for 2015 or 2016. It'll be 2016 because it's an early conference.
Yeah, absolutely. I think it's especially if you're in Europe and you're interested in this kind of stuff, you should definitely go. But let's talk about continuous integration, because that's something you said you were thinking about a lot or focused on a lot.
Yeah.
And I gave a talk. It was a Puppet talk back in 2008, I think. And I was riffing off another talk. It was a talk that kind of inspired me, both in the topic and in the delivery, from the Ruby community. Brian Lyles. I don't know if anyone's ever seen this talk, but it's called "Testing All the Fucking Time."
Sounds like a Ruby talk.
And it's a great talk, and you could Google that right now, and you could watch it, and it's a great talk. And then one of the things about that talk that I thought was interesting is, and at the time I was working on Puppet, and when you're trying to test infrastructure, it's a totally different game than trying to test unit tests. Like there's no thing that isn't kind of by definition an integration test or a functional test, and the cycle to run a test on infrastructure is so much longer that like it totally changes the mindset of all of it.
Yeah.
Where I don't know what everyone's background is when they think about things about a pivotal. And some of my earlier experiences with software development, the life cycle, the way I was trained to write code is basically red, green, refactor, right? Like you have this cadence, and then I was taught that your red and your green should be like short taps, and your refactor is the long tap. So your cadence is like short, short, long, short, short, long, and it's red, green, refactor, red, green, refactor. It was like beat into my head from the XP guys. So then when you get to the point where you're trying to do infrastructure as code, test-driven development, and all of a sudden, it takes however long to even boot something, then I don't know. I always thought it was an interesting, almost impedance mismatch between the kind of infrastructure as code mindset and the test-driven development. And I'm just curious, like, where you think that is. And I know there's a lot of things people are doing. Some of them I think are good. Some of them I think are maybe not as beneficial as people hope they would be.
Yeah. So I think one of the issues you have is people are used to unit tests running really quickly. There's in my mind there's two different things people do. You and me both hang out with a lot of people that write tools that are for system administrators, so something like a Puppet or an Ansible or a Choo-Choo, right? And there's people who are trying to test those softwares themselves, and then there's people trying to test whatever they wrote in Puppet or something like that. And in both cases, it's important to test, but you get pretty far away from anything you're holding in your hand pretty quickly. And I think, because I've been involved in the Puppet community not nearly as long as you have, right? Because you helped them kick that whole thing off, but I've been there for like 4 or 5 years. And it seems like every year someone tries to build something that allows you to test Puppet code before you push it off to your actual servers. And nothing has successfully captured enough of the people that it's become the standard thing that we rally behind, right? But they all share a certain number of either using a container or using an LXC or using Python or using virtual machine. And you kind of boot something and you run some Puppet on it or whatever. And then you do something else at the other end to check to see what happened at the end. right? And anything that looks like that ends up having so much synthetic failure rate that it becomes annoying to do, annoying to keep those tests running, and it really hits that impedance mismatch you're talking about, where you can't write code and test it at the cadence you want, because you're going to write code for 15 minutes and test it for 45.
I think you just brought up one of the other things I really found difficult to capture in that type of a test is that in the infrastructure world where you're actually, it's no longer, you're dealing with abstractions, right? The things that say they will pass won't pass when you run them on real stuff.
Mm-hmm. Mm-hmm.
That happens enough that it's annoying, right? And I think part of the reason is that when you capture tests, that the logic of your tests and the logic of your code are basically a mirror of your assumptions about how reality works. And then sometimes when you meet actual reality and it doesn't work that way, then you get a little bit of a rude awakening. Or, hopefully it's not on production servers. I do think you can mitigate some of your surprises with these types of approaches, but I've never found where you can totally get to the point where you can just fully trust everything. Like you can get, I don't know, it seems like you could get much more confidence in the tests that you build up around abstractions than you can about the things that are going to kind of touch the dirty reality of reality, the dirty real world.
Yeah, so something like, any of the configuration management systems that, so I think with configuration management camp, I think Mitchell started talking about old style configuration management tools, which are typically written in Ruby, and typically have that idea that we're going to have a long running system and we're going to mutate it several times throughout the day, and keep it online for possibly years, right? That's largely fallen away because people want to build immutable infrastructure. Right, and that immutable infrastructure, more than anything else, is an advantage because you're not calling out to some Apple server somewhere, right? You're not asking Ruby gems to do any work. You have no network bandwidth that you have to spend. You have nowhere that a TCP timeout can kill you. And so that's one of the reasons it's better. But the other is that the universe changes around you. Like you have control over your code and your Git repo or whatever. But 2 hours later, when you run it on a different system, you're running the same code, but someone has pushed some new package to some place that has broken the dependency chain, and now you can't install anything.
So this is like next level, or kind of 2000 level introduction to change management, right? So in what I consider
I wonder if my internet busted.
The more mature approach to building these things or doing kind of web operations, you would never build anything against the upstream public repositories. You'd always have some sort of private repository that was part of your change management that you would bring vetted packages into, right? So like you're going to run your own Yum or whatever Debian packages. That's what mature people do. Right, like if you're not doing that, like you're basically, and as I said at the conference we mentioned last year, I said if you're going to just pull random stuff, like you're just exposed to like whatever, right? Like you have the ability to control that. Like you can run local gems, you can run local everything. I think that now the point you're making is also very, very interesting time. I mean, especially when you look at the way the rest of these tools are going. I knew you were doing Puppet stuff, so that's kind of where I started with that. But the ability for you to build a composable, like fully specified container that has all of its dependencies inside of it, and then test that mitigates a lot of what I was just talking about when you go to like run something against reality.
Mm-hmm.
I still don't think we got everything solved when you start to think about like topologies of networks and like a bunch of this other stuff that goes on and keeping promises about all that stuff. But the ability to do an immutable, fully specified packaged container that has all of its own dependencies, then you can test that with a high level of certainty, much higher level of certainty. You're probably, I don't know, I've seen some pretty weird stuff where people because of something that's like slightly different about a kernel, it will have weird behavior. But other than that, everything is much more predictable.
Yeah.
Uh, I did a rotation on the Bosch team like a couple of months back, and their test suites are pretty interesting. So Bosch has this concept of a CPI, which basically is the cloud platform interface, and they just wrote like all the logic for all transactions are encapsulated in a dummy CPI, which doesn't actually talk to the IaaS, but assumes like IaaS can do its thing. And then the CPI itself has its own bunch of tests which run against the IaaS and try to test those interfaces. So that was a very like I was quite amazed at the rate at which you could do development for the tool, where you're running a complicated integration test related to what the system should do, and just expect something of it in like about like 20 seconds. So it's quite an interesting way to test the code.
So you're talking about the value of an abstraction layer that has
Yeah.
basically mocked the API
Yeah.
for the infrastructure.
Yeah.
And so you don't, yeah. So inside Bosch, you don't code it to Amazon or to OpenStack or anything. You code to the CPI.
Yeah.
But then isn't there's tests for the individual CPIs as well, but then there's
Yeah.
a bunch of logic around like the CPI doing the right thing. They like
Yeah.
assumes it'll do the right thing.
Yeah. So
So at what point do they actually start, like in the CPI's tests, do they run against real infrastructure, or is it all just mocks all the way down?
they run it against the real infrastructure, as far as I'm aware. So I
When
was
you-
not on. Yep.
When you're testing the abstractions of Bosch, then most of that gets mocked against the like abstraction of the CPI. But then there's there's specific CPI tests that guarantee that the semantics of the underlying APIs meet the contract.
Yeah.
If that makes sense. So it's like
Yep.
you assume that okay, if I make a request to get a VM, I get back a VM, and then you can write a bunch of logic around like what that should do, and then
Yep.
you have a specific test for Azure and one for Amazon and one for
Yep.
OpenStack or whatever that say like if I make this call, do I get back a VM? And then it
Yep.
checks that it meets that contract.
Yep.
Does that make sense?
Yep.
Yeah.
That makes sense.
How much of that is hot? Is it and their actual tests for CPI that run again that'll actually boot VMs in Azure or whatever, or is it a kind of a trust thing?
No, they do. The ones that are Azure specific tests, it will boot it against Azure. The ones that are just a test for Bosch's logic,
They just hit
that will live in the mock, right? Like that will live in the world of abstraction. But then you make assumptions that you can meet these contracts with, like the Bosch CPI has about, what is it, 18 calls or something now, 16, 18 calls. It's like get a VM, list all the VMs, delete a VM, do some things with the network, connect things to disk, get disk, delete disk, whatever. Like so, you could check that layer. Those are kind of like your system calls or whatever. That if those
primitives.
if those primitives have the right semantics with that API, then the rest of the logic will work. That's the kind of the assertion. And if it breaks on something, then you go back and make sure it never breaks that way again. But
yeah, you hit the 99% case pretty fast there, I think.
yeah. So what do we have CI on Azure or APIs right now for Bosch? Do you know?
So are you asking CPIs or APIs?
The CPIs.
So the Bosch team directly supports, I think, vSphere, vCloud Air, OpenStack, and AWS. And Microsoft is doing some work on the Azure CPI, as far as I last know.
So the only one that's not getting love right now is the Google Cloud, probably.
Yeah.
That's at least by us. I know there's a CPI is in the open source.
I think it gets outdated pretty fast, like the open source CPI. I'm not sure. Like it doesn't do everything. Like Bosch requires you to write I think 12 core functionalities are necessary, and then there are these like optional functionality which you can implement in your CPI. So you won't get all the niceties of BOSH, but like some things will work on Google Cloud.
Interesting. I haven't made a lot of experiments on that cloud, but whatever.
Yeah, I've booted about 4 instances on Google Compute in my life.
So are you on the same team as like Jesse and those guys from Blue Box?
No, I report. I mean, depends on how far up the chain you look. I work for Monty Taylor, who's been named the, I don't know, like the director of OpenStack innovation. So I'm in the cloud mobile vertical.
Okay.
And our team is specifically built around finding and solving performance bottlenecks in OpenStack.
So were you on in the same kind of group at HP and then came over? Is that what was the?
Yeah, I was under Monty at HP. I was tasked at building out a team they called Gozer at HP. So, well, not building it. Building out makes it sound like I was like in charge, but I wasn't. I was just an engineer on the Gozer team. And so the Gozer team was the CI system inside HP. So OpenStack is pretty proud of its infrastructure project, which I work on. And so Gozer was building the same system internally for HP. So if an upstream developer pushes a patch to OpenStack, it goes through a process. And the same would be true of HP. So if HP wants to have a downstream patch against OpenStack, it goes through the same code review and testing process that it would have gotten upstream.
Interesting. So then your kind of scope or the way you think about CI, you think that it's very infrastructure centric, or how would you frame? Like, I don't know your background, but it seems like it's probably more like ops and infrastructure centric.
Exactly. So I'm pretty new to the game. Let's be real. Like I don't really have that much experience. I have a lot more to learn than I have to say.
I mean, I think that's true about everyone, but
yeah. And that's not just imposter syndrome either, right? Like that's just, let's be real. I haven't worked on that many projects, and that many projects have been successful and stuff. But yeah, I came out of working as an operations and working as a system administrator or operations, whatever you want to call it today. And so when I'm thinking about testing, I'm almost always thinking about testing something right before it deploys, or testing what I'm going to change to a server or something like that. Just these are the tools that the open source communities I run in, the things I work with. I'm not as familiar with, kind of working actually in the application code itself before it deploys, or something more like a unit test. So especially where you look at like the gnarlier parts, because of course in my work with OpenStack, we do a lot of unit tests, but those aren't the things that are kind of interesting from a CI perspective. It's kind of like, well, we run the unit tests, and then that was that. There's not a lot of engineering to do that right now. For anybody who doesn't know, what we do at OpenStack is we have a kind of an all-in-one shell script that will bring up a lot of OpenStack services, and then they cross-talk with each other during the test. And as a result, you can kind of get a feel for how it would have behaved in production, and we can fail or pass based on those behaviors.
So is that the DevStack thing, or that's something else?
Yeah, I'm talking about DevStack right now. Yeah.
So then, I mean, one of the things I don't want to get too sidetracked, I guess here, but the way that OpenStack is conceived and the way that you're building it, I mean, it's also interesting from the perspective of the stuff that we work on right now at Pivotal. Like, how much focus or how much awareness or how much thought do you have around what will these actually provide? Like, what services, what applications? Because it seems like there's a little bit of a disconnect sometimes when you get so focused on the infrastructure, like enamored, fascinated with infrastructure, that you lose sight of like the reason that infrastructure exists.
Absolutely. And the simplest case, inside where we test OpenStack is we run essentially one virtual machine, and that virtual machine runs a handful of services. And the infrastructure layer directly under OpenStack is not complicated. Clark Boylan, who you may or may not know, has done a lot of work to make it so that in the CI pipeline we can actually deploy OpenStack on a multi-node system, in a multi-node kind of way. But that hasn't seen large adoption yet. Most people aren't. It's kind of paradoxical because for a long time every OpenStack developer has been clamoring for we would like to test multi-node, and then now multi-node's available, and there was not a great rush to actually get on the boat. They just wanted the boat to be at the dock. What are you gonna do, right?
Well, you could always kind of massage DevStack into doing multi-node.
That's exactly what's happened.
Okay, because that was like early days when Jesse Andrews was working on it. You could do multi-node deployments with DevStack. You just had to know how to like set the right environment variables or whatever and massage it along the way. But
yeah, interestingly, it's not to cut you off, but it's morphed a little bit and grown some Ansible components, which makes the multi-node orchestration much simpler.
Yeah, I can imagine. I mean, I haven't really touched it since probably 2012.
Yeah.
So kind of going back to the question, I mean, the way that we frame the world from the pivotal perspective, and a lot of our focus is obviously like Cloud Foundry and, you know, even farther up the stack when you start talking about Spring and Spring Boot and the rest of that stuff. It's like it's very application centric.
Mm-hmm.
And so for us, you know, kind of going back to Shar's comments, like we basically just want that contract with the infrastructure to be met with the things that give us the basic VMs, compute, some network stuff, although I think that will evolve. It's definitely already kind of getting some attention. And then disks. Like sometimes you want to attach disks. Obviously you want it. So that sort of thing, like if that is met, that contract's met, then you can go and do the thing you want to do, which is deploy applications. So I don't know, like I don't really know how to make this a direct question, but it feels like in my experience, and we still see this, and I would love to be able to capture metrics with something like Bosch, but the way that OpenStack deployments get made, and I'm sure you know this as much as anyone, it's hardest for us to kind of know that the contracts will be met when someone says they have OpenStack, because you kind of have to go and then like we end up, our team that does services and delivery right now on Cloud Foundry has quite a bit of OpenStack expertise for this reason, because like almost always when it's an OpenStack based deployment, like we have to fix their OpenStack before it will work.
Right. So there was a Twitter conversation. I think I know what you're talking about now. So there's a Twitter conversation. I don't even remember who it was, but I think it was Jeff McCune was mad about. Or no, he wasn't mad. He was just having a good time. And so I think, Kelsey Hightower is like the.
When sysadmins are having a good time, they look like they're mad. So
I'll use words like get mad for people who are not actually angry, just because if you make a controversial point. Anyways, so somebody's like, I think it was Kelsey Hightower, was like, the data center is an API. And Jeff McCune comes out and he's like, well, POSIX is an API, and that's lived for 40 years, you know? And so what your CPI, you know, your primitives inside CPI are kind of the primitives that we want to be able to meet, right? And the CPI abstraction layer, I think, you know, I've literally learned about it in the last 15 minutes, but it's that classic, we would like to provide to our application a few primitives that make sense, and then you just write some driver code for every major thing on the other side of that. And there's one Azure, and there's like 1.5 Amazon, because US East is always a little different. And those are like tractable problems. What OpenStack is it might look like a single problem or one OpenStack, but when you have maybe 10 very common services and a quickly expanding number of deployment opportunities, it doesn't end up looking the same, whether it's a public cloud or a private cloud or a managed private cloud or a dev stack. And so it becomes hard to know and to test. And yes, what I've heard from a number of people is that they've built out, anyone who really wants to make sure their thing works with OpenStack ends up building essentially a brain trust of people who can be counted on to figure out what's going on with OpenStack, help the customer with OpenStack, and somehow bring sanity to the world of the little small differences between one OpenStack deployment and the next OpenStack deployment. And it's a problem that's being worked on in perhaps not the best way, but nothing that is surprising to people in the OpenStack community.
Yeah, I don't think it's surprising at all, right? Like, there's been the effort to create and define DevCore forever, or DevCore or whatever, and that's, I don't know. I watch a lot of the OpenStack stuff. I still get some of the emails, and it's always sort of interesting to see like the same conversation get recycled for the
Hmm.
last few years. But the problem is almost not that there's like all these different services. It's like the combinatorics of choosing different things, like
Precisely.
the hypervisor here, or the network model there, or like this storage driver there, and then all of a sudden like it doesn't quite work exactly the same way. Like the semantics changed.
Yeah, so there's a few different services in OpenStack. Generally, you're going to in almost all cases you deploy the services. Um, and there's obviously version differences there, which is not the problem. The problem is that OpenStack is an abstraction layer on top of infrastructure with um, a multitude of deployment options on the other side of it, right? So you could use Zen or KVM for the hypervisors, the classic example. And that's all well and good, and you say provide the same compute API to your humans who are trying to use your OpenStack. But the rubber meets the road, so to speak, when you want to upload an image. Like in Amazon, you call it an AMI. We call it a glance image, whatever. You now have to know what the underlying hypervisor technology is on that
Absolutely.
OpenStack cloud, because you either have to upload a QCOW2 or an HVM image. And worse, it's not discoverable right now. So you just kind of need to know, oh, this is Rackspace. They use Zen. I have to use OVH or HVM. I send an HVM image up. Now, like it or not, there's a library they've been writing called Shade, which, at least if you're using Python, has taken the effort combined with something called OpenStack Client Config of simply enumerating the most common clouds and their deployment particulars. So if you import Shade, you can type shade.image upload, and it'll get it done properly, whatever the actual answer of that was. This is not perhaps the best solution, but it is a solution that's being proffered.
It seems to me that you'd want to make that discoverable.
Yeah.
Like lots of the stuff inside of any of those services, the services should be able to tell you what they provide and give you some hints about what their semantics are. Right?
Yeah. It would be better, I think, if there was a standard way of doing it. Right.
So let's get philosophical about cloud software, because in some ways there's hold on, let me see if I can actually find the slide. So this was from the Recon. Recon.
What's Recon?
It's like a Basho's. Basho has a conference where they talk about all sorts of distributed system problems and the kind of stuff they do. Let's see if I can find this.
Is like the Re and Recon, is that from React?
Yes.
Okay.
So I don't know if I can find this, what I wanted, but let's see if I can find it. So it was a Ben H. from Mesos, Benjamin Hindeman. Let's see. Talk amongst yourselves. I'm just trying to find this this photo of.
The slide?
Yeah.
What year was it?
Just happened like a few months ago.
Okay. Yeah, I think the central problem is that, I'm just parroting words from people who I think are smarter than I am, but if OpenStack provided a strong abstraction over infrastructure, the deployment details would be unknown and irrelevant, and there wouldn't be a need to discover it because the abstractions would be good enough that you wouldn't need to know or care. That's maybe a pie in the sky, but that's where it is. Interestingly enough, DreamHost has done this kind of correctly in the sense that, like, if you upload an image to DreamHost, you're uploaded in RAW format, which you could argue is the kind of least common denominator in terms of disk image formats. And it's because they eat it in RAW and then they put it in some Ceph cluster somewhere that's engineered somehow so that it can boot that way. They're not married to, well, they're married to something kind of custom built in-house, but as a result, they've wandered into what they think is the lowest common denominator. Again, the user just needs to figure that out, though. Although, it's interesting because if you're one person trying to use OpenStack, is it a common use case or not to have to hit multiple OpenStack clouds run by different people with different deployments? I don't know the answer to that question.
All right, I found it. So this is a slide from his keynote, and it says perspective. And this, I'm going to kind of like smother this all over anything that has to do with cloud software because I think it should be true. Distributed systems should be able to operate themselves, deploy, monitor, update, upgrade, etc. Does that make sense?
Do you want to share the slide?
I can show you. Actually, I could share my screen. Let's do that. Hold on 1 second. That's the screen. The closing keynote at Recon from Ben, who's a founder of the Mesosphere. So back when I did OpenStack all the time, one of the things that I got really frustrated with, which I essentially feel is embodied in this slide, is that I don't know. Ceilometer was sort of like this breaking point for me because it's like you have a project that's starting on the side to gather metrics about a system that I feel like the system should just tell you, right? Because you already have all these things that you're trying to gather metrics about in the system. You are building an agent, another agent, that's going to go and count like how many times this one thing goes on the message bus. Like, why don't you just do that with the thing that's already?
You're saying why isn't it a first-class citizen? Why is this being tacked on later?
I mean, I think it's just a fundamental understanding of how a cloud, what I'll call cloud-native application or platform should operate, which is that it should kind of know its own health. It should know its own metrics. You should be able to query a running application that's been designed as a distributed system, and you should be able to get back information about its health. Its usage, like whatever metrics you think are important, that should be part of the application, not a secondary thing. And I know we're like in this weird kind of transition state as an industry where all these things are piece parts, but I think that if you look at what this kind of goes back to what I consider the mature web operations that happens in the cloud native companies are building, things at scale, operating with scale. Like they have a very particular opinionated way that they do deployments. Like the things that you see at places like Netflix or Amazon or Google is not as varied in their architectures as what you find in the average. Even though their scale is much more massive, their actual deployments are less varied. And as a consequence, like they've made these opinionated choices about the architecture, and then part of that is the way that it scales, part of that is the way that it's monitored, part of that is the way it's all these other qualities and factors that they could make promises about. And I feel like the way that a lot of these other projects have evolved is much more like trying to accommodate for all that variety, which actually prevents you from doing things that you would hope to do as effectively as you'd want to be able to do them, because you're trying to accommodate every possible use case. You're actually hurting, your 80-20. Like the 80% of the stuff that you should be doing all the time easily is actually harder than it should be. Anyway,
yeah,
mostly philosophical, but that's I don't know how the conversations are evolving in OpenStack because I'm not in the middle of it anymore. But you're definitely seeing interesting conversations around these sort of distributed systems and how to build them in the communities that are happening above OpenStack. Certainly in Cloud Foundry, certainly in the Mesos. This is the founder of Mesosphere. You're seeing that kind of stuff happen in the Kubernetes conversation as well. So just from the vantage point of someone who's working on CI and OpenStack, I was just curious what your what you're seeing there, or if you think that will. Do you think that there's a voice for that or a stomach for that, or is that something that even matters?
Not entirely sure I understand the question.
It was a long, rambling, imprecise question. I guess that to try to make it more clear is the nature of these kind of infrastructures. An infrastructure as a service is a distributed system.
Mhm.
In the evolution of OpenStack, do you see that kind of, I guess, formality and rigor coming to the conversation, or is it more about, or always going to be about, let's just write a thing, and then it'll be like a thing that doesn't necessarily, it passes the test to the level that we made it pass, but it doesn't have to know its health. It doesn't have to deploy itself. It's kind of
Well,
like
I think
this.
when you talk about that, it makes me think of the 12-factor app web page that always gets linked around, right? Like the
Sure.
responsibilities of a daemon, right? And right now there is, and so the idea is, again, I don't have that much experience with development shops, right? But as I understand it, the idea is somebody gets that page and they socialize it with the engineering team, and then everything that go on, they write from that point on, has a simple contract. It's responsible for doing these things.
Yes.
This is how it should consider itself, right? And whether you like those specific 12 lines in the stand or not, the conversation becomes, when we write a new thing, these are how it should interact, and that makes it easier for everyone to reason about things they did not directly write, and it makes it easier for operations to support it and stuff. And right now, we don't have a shopping list, a simple list of these are the responsibilities of an OpenStack daemon. When a new daemon comes up, it should not expose a new compute interface. You're not really supposed to step on other daemons' APIs, but it's kind of the Wild West in terms of how you write it and where its lines should be. Although there's always pressure to reconsume as many existing OpenStack APIs as possible.
I hope it's gotten better since I was involved, but when OpenStack was something I was focused on all the time, each new project that got spawned essentially started its own conventions for almost everything.
And you should remember that, I don't have the best perspective. Like, I run around doing a job that's almost perpendicular to the real direction of the development of OpenStack, right? I have some perspective, and I
Sure.
hang out with these people all the time and stuff, but I'm not a core contributor to Nova or anything like that, right? So I'm not entirely sure.
But in some ways, like this, CI is where everything happens. Like
Yeah, well, it's where the rubber meets the road, right? Sort of.
It's where the code meets the silicon.
Yeah. One of the interesting choices we made to completely talk about something else is,
By all means.
so, for instance, if you're configuring a CI system, in my mind you have two choices. I'm sure there are more choices, but Travis CI made an interesting choice, which is the only choice that Travis CI had available to it, right? So for every GitHub project, there's a .travis.yaml. And so every Git repo essentially describes its own tests. That's one way to do it. What OpenStack has done is the exact opposite, where anyone who's writing tests against any project in OpenStack, instead of a file per repo, we have a central set of files that inform testing for all other projects, right? And this provides a problem, but also a benefit. Like, the problem is that people have to leave the repo they're most comfortable working in, go to a different repo and make changes there. But the good thing is we can centralize it. So if we're running just Python unit tests or Python lint texting or whatever test is, we usually have one test definition, and then it gets reused everywhere else. So as developers hop from project to project to project, there aren't a different set of flags to the linter. There isn't a different way that this test is being run. That's the same entry points and expected behaviors coming out the other side of that. So that's pretty cool. And that's an example of where it doesn't matter until it's tested.
So the current configuration for OpenStack CI is that the repository for tests, there's a single repository for all tests for all projects?
Yeah, and this maps It defines all the tests and then maps all the projects to the tests, right? And there's many mappings there.
So, but all the tests are in that repo.
Yeah. Well, all the entry points for tests are in that repo. The tests themselves are co-located with the projects. But
Okay.
but for instance, the shell script that gets us up to the point where we can run talks is in that repo.
Okay, so that makes more sense. So the repos for each project have their tests for themselves.
Yeah.
But then the centralized, it's sort of like what do you, are you guys using Jenkins, or what's the actual?
Well, how much time do we have? But Jenkins is
We
involved.
got a while. I
um,
mean, I'm fascinated with this stuff. So, like, looking at what's going on with stuff that we do around Concourse,
yeah. Is that
or
your kind of CI central thing?
that's what we're moving to. It's a CI system that was developed when we got too frustrated with the capabilities of other ones.
Sure.
Basically, the way that I think of Concourse is it's kind of the first CI system that was conceived of after the fact of kind of like modern microservice architectures,
Hmm.
where Jenkins in its, I mean, it's nothing against Jenkins. It's just that it was born into a world where the fundamental assumptions of what you were CIing were essentially monoliths,
Hmm.
and then as a consequence, like the types of things that you could do to build pipelines, it's not that you can't do them. It's just that they tend to be clumsy and brittle.
Sure.
And then there's another tool that's sort of, in some sense, I feel like there's aspects of Spinnaker, which is this tool that just came from, was just open source from Netflix. That was built with some stuff that is happening around our projects, but it's kind of a marriage between Bosch, where it has some integration into the underlying clouds, and then aspects of the pipelining from Concourse to do kind of like uh, continuous delivery models that are integrated with the underlying infrastructures.
Yeah. So I want to put the integration. I really want to talk to you about the integration at some point in this call. But
Let's talk
um,
about it now, unless you have another thing you want to say right now.
well, no. Anyways, so I'll talk about that a little bit later because I really wanted to. That's when I wax prophetic about what cloud is.
Okay, let's do that.
Okay. All right. So there's I don't know
Take us on a journey, Spencer.
how much Google Compute have you done? Have you done a little bit of that?
Enough to know that like it works pretty well.
Yeah. So here's an interesting thing, and I don't know. I haven't really done that much with like Amazon or Azure, but one of these things you cannot do with OpenStack. So, and this goes back to the slide you showed, right? Which is the idea of, and CI systems do this. It's this idea of like a feedback or a reflex, right? So maybe as an operator, you have credentials to the cloud, and you say, I would like to boot some instances, all right? And then the instances run the applications or whatever, right? And then there's this moment where you give your instances more credentials or the same credentials so that they can boot their own instances. And at that point, you've created an interesting sort of like a little feedback loop where it feeds itself and it takes its own and where I'm used to the idea of like, especially when I'm talking about authentication and access rights and stuff, I'm looking at kind of like a top down. There's some kind of like a root credential that then has sub-lieutenants that have credentials that have authority down here and stuff. I think other people are probably building, and they have the technology to build things that are just totally decentralized, and all it is nodes actually have the ability to shoot themselves in the head. So what Google Compute does is Google Compute, every time you put a Google Compute instance, it has it in Etsy somewhere, some credentials that aren't fully powered credentials, but for instance, you could have a script in that instance that will go ahead and change its own networking significantly. It can add itself to a private network. It can change its own routing table. Not the routing table, not just like the IP tables routing table or the NetApp routing table, but which router it's actually using above it and stuff like that. It doesn't have the ability to delete itself, but it has this idea of master of its own domain. I was wondering if you've seen patterns like that and whether or not you think it's a good idea. What workflows maybe come out of that?
So I think it is a great idea. I think that, I mean, I almost want to take it a step farther. Not that this is how things are being done right now, but this is kind of like my dreamland, is that every instance of everything should have a unique cryptographic identity that's
Mm-hmm.
authenticated and authorized to do certain things.
Okay. So
Right?
we'll bring
So like,
Kerberos back.
in a sense, I mean, I think that you go through like the cycles where everyone, and I made this comment recently, everyone reinvents Corba, everyone reinvents Kerberos, everyone reinvents like certain patterns. Except for here, it's actually like when I start a VM, then like basically what you're saying there is it has a certain credential, right? So like that is an identity for that VM on that cloud.
Mm-hmm.
Now when I start a bunch of containers, why shouldn't they have identity, right? And then
Exactly.
when I have a bunch of, so like I kind of want like these hierarchies to be both explicit but at the same time decentralized. So it's like if I have a microservice, then that service should have an identity that is, but then like each instance of it should also have a sub-identity. And then you should probably, like if you're really trying to do this the right way, have like a lot of that, all of that cryptographically signed. And if you're going to do it really the right way, then basically all the way down to the TPM modules or whatever at the hardware signed up through every deployment of the code. So like you could really have this chain of trust and then an identity and do...
Yeah, and if you've cryptographically signed some kind of a credential that is on the instance, then you have like instantly working integration with like a secret server, right? Because it's 2015 is the year of the secret server.
The year of the secret server.
Have you heard that?
I have not heard that, but I have seen, I mean, there's interesting stuff going on with Vault and some of these other projects.
Exactly. There's like 4 of them came out this year. So somebody coined that phrase, and I've been repeating it a lot.
I will start to use that. Although I think that the 2015.
We should look up who it was so that we're not biting. But yeah.
I think that the secret server stuff will come into its own. I mean, one of the projects that influence somehow I think about this is conversations with the guys at and the girl. It's not all guys. One of the founders is a woman who's quite intelligent about this stuff. Conjure is a startup in Boston that does this kind of stuff. That was also used. I think Netflix is using them for some stuff, but they kind of have the underlying scaffolding to like make your identity like keys or whatever, the UUIDs and like the kind of what you can imagine that building that would look like. They already build it.
Yeah.
Quote unquote as a service.
Yeah. Well, the simple thing in terms of like what are those cloud primitives, right? Everyone's chasing that. But you might imagine an instance would come up, and it would be kind of cool if it had the ability to just provision some long-term storage, right? And then it could just back itself up, and you wouldn't need an orchestration layer on top of that instance. You wouldn't need to connect
Absolutely.
anything.
I think that the general theme that you're identifying, which I think is the correct one, is decentralizing autonomy and responsibility,
Mm-hmm.
and then allowing those actors. I mean, this is where you get into like a truly complex adaptive system where there are essentially agents that all have behaviors, but they're not necessarily fully orchestrated by some centralized controlling process.
Yeah.
But
what are the things? Yeah.
These types of systems can get really difficult to reason about because the emergent behaviors can do things that you don't are not easily predicted. I'm not saying it's right or wrong. I think that it's a ways away before most people are going to have the level of sophistication or comfort to run everything with like the nanites that kind of like self-build everything.
Sure.
But I do think that that's aspirationally where things should go. I just think it's a ways away from most people.
Yeah, and I'm not sure how the other cloud providers work, but so I have a number of OpenStack credentials, and I've had more in the past. None of those felt like they were fine-grained credentials, right? Like a central point because you want to be able to provide a credential that's capable of doing some things but not other things. And I haven't seen that come out of OpenStack. It might exist that I'm not aware of, and I don't know what Amazon credentials can do or not do.
Amazon has
ingrained at the
the IAM stuff that Amazon has is getting really sophisticated. It's a little different than the way Google's model work. But you don't, at least that I've seen, you don't have those identities for the VMs, but you have ability to give each user a bunch of different kind of access controls for the different services and infrastructure.
That's perfect, yeah.
So instead of, in the old days, like everyone on the team would have the same credentials for Amazon.
Yeah, just the shared password, right?
Well, it's the shared keys or whatever, yeah. It's not really password. It's like the you need the two things and you can put it in the API and it works. But in the new world of Amazon, you can have each person on the account will have their own credentials with different kind of fine-grained role-based access to parts of the infrastructure.
Yeah.
And that's, I mean, you're just seeing the evolution of those features as they get more kind of conscious or customer focused on the enterprise that wants to have or needs to have more granular control of that stuff.
Yeah.
But I actually, it was funny. This was just last year. It wasn't. It was maybe 5-6 months ago. So I used to have an Amazon account. I used it a lot in, say, 2009, 2010. Then I kind of like didn't really use it for a while, right? Like I just did a bunch of projects, or like if I did anything with Amazon, it usually wasn't my account, and it would just be like, give me the keys, and like we would put some stuff together with some automation, but it wasn't really my account. And then it was for the Interop conference in Vegas, and I wanted to make a new one to do some demos. And so I went through the actual process of making a new account. It was a totally different experience, right? Like all this IAM stuff and the way that the account worked with authentication and two-factor and a bunch of things that just like our kind of best practices now is a totally different experience than the Amazon of, say, 2012.
Yeah. Did you also get caught up on like VPC by default and all that? Or was that?
For what I need to do, that didn't hang me up too much because I knew, like I just needed to get to the point where I had keys and then I had a bunch of automation that I was going to run, right? So I just needed to have, like I already had Terraform and I already had a bunch of stuff, so I just needed to get to the point where I had credentials.
Yeah.
And then like feed those into the automation that I already had. So it wasn't like I was trying to figure out, like all the stuff you just mentioned or getting stuck on it, because I was like I already had a particular thing I wanted to accomplish. I knew that it worked. I'd had it work in these other accounts. I just wanted a new one to do it on, so that like really all I was doing was going through that initial setup, and it kind of blew me away. I was like actually shocked, like how much it evolved.
Yeah. All right. Well, let me show you some cool things about our CI system as long as I'm here.
All right, let's do it. You want to share your screen?
I do, but only for like 10 seconds because one of the more interesting things about our stuff isn't even in the CI system itself. How do I share my screen?
There's a little green. There's a green thing. If you go the, well, we lost him.
Yep.
That didn't work.
Yeah. Probably will get back on.
He can just click his link. He'll come back.
Hello?
And he's back.
Wow. Okay, well, that's what happens when I try to share my screen.
It just crashed Chrome or whatever browser?
Yeah, I don't know. I'm not in charge. Here, I'm going to send you a link. You can open it up, and then you can share your screen.
If you go okay, that's fine, too.
Yeah.
Just for future reference, if you go over to the left side, there's a green rectangle that says share screen.
I pressed it, and it seems to have... Here, I'll press it again. We can try again.
We'll do some science if we lose Spencer.
He went again.
That did not work. All right. Now we know. All right. I got it. Spencer cannot share his screen. That's the rule. All right, so here's what we got. Okay, we did it for science, and we know now that you can't click that.
We have repeatedly tested, and we know. So here's the cool thing, and I don't know what you want to call it. What we call it. So this is our code review system, which is may or may not, which is not GitHub, which you may have figured out.
It's Garrett.
It's Garrett, right? And everybody likes to shit on Garrett, and I'm not going to apologize for its UI or anything.
Garrett's all right. It's opinionated.
Yeah, exactly, right. So here's what's really kind of cool about it is that
Tell me if you want me to click on something.
No, you're fine. You're good. And this is a relatively new change, so I think this was updated like 5 minutes ago. So, well, what has happened here is on the left side you see, or in the middle left, you see all the reviewers, and there's some humans there like Michael and Maxime, and there's a Jenkins user, and then there's all these names of things with the word CI at the end. And so what we do in OpenStack is we simply allow anyone to vote on code, right? Anyone can say this code looks good to me, this code looks bad to me. And we allow any organization that wants to run their own CI system. And so the Jenkins account that you see there, that hasn't voted yet because it's a relatively new change, so it's still running tests. But what will happen is Jenkins RCI will officially run, but then while that's happening, Intel CI and IBM CI and the Zen Project CI, a robot inside those firewalls will actually pull this code down and run run some set of tests, usually the exact same tests that we run upstream, and then vote. And you might say, well, that's kind of stupid to just run the same tests, but like especially in the IBM Power KVM, what they're doing is they're making sure that it runs on the specific gear that IBM or Intel or whatever has. And so we call it third-party CI, where someone who's not directly involved in the development of the software is able to kind of say, hey, for whatever reason, that has broken me. And so usually these things all vote together. Like if the code simply doesn't pass because you have invalid Python, they will all vote fail. But sometimes.
So interestingly, in this example that we just have up, the Zen server CI is already voted -1.
Yeah, and I'm not going to try to like review and try to really analyze what's happening, but yeah, basically whatever Citrix is doing has somehow whatever change, and I'm not. What is the content of this change?
It's about It's like the vRouter stuff in OpenContrail.
Okay.
So probably something about the different networking models.
Exactly right, and that's where it can become really, really useful. So again, we talked about DevStack for about 15 seconds. DevStack is a script that will set up a bunch of different daemons in a specific configuration, and from manipulating environment variables, we can really affect what that configuration is. And so, yeah, if Zen server is doing something creative with networking and they're screwing with OpenContrail in this patch, it's totally believable that it would have busted, right? And they can provide that feedback. And maybe it's a docs change, maybe it's something Citrix needs to do, but as a community, we can kind of move all these perfectly functional deploys forward and make sure we don't break them. And that's really cool because you don't have that, I think, anywhere on GitHub. And just in open source projects, the idea that anybody can take the code that we have not released yet, try it in their configuration, and report back on how it went. And then we as developers will answer for like, oh yeah, either we get to answer for it through whatever. You could take it off the screen now. It's not really that important. But that concept, that little trigger, is really, really cool.
Let's see if it'll let me. Does that zoom in for you? Or does it?
I mean, it looks fine for me.
I was trying to zoom in on the specifics of the different robots.
Oh well, I guess part of what you can do, because I almost never do this right, but you can click on it. No. If you go to toggle CI, at the bottom, you can click on their logs actually and see what their log has to say. It doesn't really matter, but so any developer can read their logs. I don't know of a lot of places on the internet. In fact, I don't know anything other than OpenStack where that kind of third-party CI is encouraged and supported.
No, I think that's a great example of setting up what was like systematic verification in a collaborative way. Like if any one of those is -1 is a block to patch.
The -1 doesn't physically prevent it from merging, but developers generally try to resolve it. Sometimes CI systems are not, because everything's real, right?
Yes.
And the reality is the CI system's sort of complicated inside Intel's firewall, and probably like one developer set it up last year and left for a different company. And so somebody's like 10% of one person, busy persons is like in charge of getting it working. So sometimes it's like starts failing a lot. And so we have to like occasionally disable them and stuff when they're just like obviously spamming useless -1s out of disk space. You click on the log and it's like out of disk space, and you're like, well,
I'm out.
Maybe you should check that out.
Interesting. In a sense, like that brings up some interesting parallels to democracy in general, right? So it's like the vote is there, but it's also it's only as valid as like the energy that someone kind of puts into it to keep it valid. Is there any mechanism that the robots ever get taken out of that?
Yeah, all the time.
So what will drop you off the list?
Well, if you vote, for instance, if you're just spamming -1s immediately, like the fact that it's a -1 so quickly compared to all the other CI systems is a little bit of a red flag.
Well, it ran in 1 hour, says.
Okay. Are you looking at this log?
Yeah.
Yep. I don't know. To me, this looks like a real log. Like this isn't an Insta. So you can look at it's relatively easy to construct a query to look at the overall -1 to +1 percentage. And when it's been nothing but -1s for a week, it's like, yeah, it's probably busted. And so reviewers for projects will come into the infrastructure room where I work and like be like, hey, can you disable this? It's obviously derped.
So is it your team or you specifically that adds or controls that list?
Kind of. So it's totally democratic, right? Or it's open access. Like anybody who presses the right buttons in our registration console can get a name to vote with. So you just go through the process pretending you're a human called Intel CI.
You mean just anyone can register and get it?
Yeah, and then you just have an SSH key in the CI system. Generally, the developers for the projects work together to help get the CI solid across all the platforms.
I think that's actually really cool.
Yeah, so it goes a little deeper. Thank you for saying it's cool, but there's like this is like the easy mode, and then there's this like so what are we really testing here, right? We're taking you can think of this as one direction. Right, the forward direction, whereas OpenStack has taken patches on top of OpenStack, and someone has deployed that onto probably virtualized gear in a configuration, and found out it doesn't work or does work, and reported back with that information. Right, that's one direction. The other direction that we're working on doing, we don't really have working yet, but we have, well, we actually definitely have working, is the idea that someone who controls a library that OpenStack uses is getting ready to make a change to that library. And so we'll pull in that library's master plus the proposed patch, put that under OpenStack and run the tests and see if it works. And that way we can provide feedback back to that person like, hey, if you do this thing, you're going to break OpenStack. We sort of have that working. We have that working for libraries inside of OpenStack. We don't have that working for like things on GitHub that we need, like EventLit or cryptography or whatever. But my vision for the future, and this is really pie in the sky, my vision is that there's no reason that everybody couldn't just do that for everybody else, and you just get this huge connected web of people saying, hey, if you merge that patch, you'll break me. Hey, if you merge that, you'll break me.
So
Because the other
that
yeah,
doesn't have to be even OpenStack specific, right? Like you're
no,
basically taking CI as a paradigm and extending it to the whole dependency tree.
yeah. All you do is you run your own tests, and you just modify your build step, your setup step, such that you can optimistically opt into patches that have not yet landed. And here's the really cool part of that, because we're doing it in a couple places.
Or even if the patch landed, if you just did it against head of master all the time, you'd probably
Landed but not released. Yeah.
you'd learn a lot if you're just on head of master, I bet.
Yeah, and what we found is really cool is that when we're currently broken by something, we found some bug somewhere. What we could do is we can go fix that bug in a proposed patch, and then watch the whole pipeline go green. And then we know that if we land that, we'll actually fix the problem. Because how many times have you been in that place where, like, oh, there's a bug. Okay, we'll fix this and then release it. And then, like, oh, actually, we didn't fix it. Fix it again and then release again. Right? How many times have we been there? Like a million times, right?
Because everything's Git based, and you're running off of those branches with the patch, and then you can see the whole thing go green, and then everyone, the good guys win, and there's much rejoicing.
Exactly.
Well, that's fun, and that's actually quite thoughtful, and I actually learned, which is my favorite activity.
Yeah.
So we've been a good solid hour.
Yeah.
I think I'm really glad that you shared that. I knew the OpenStack was doing some interesting stuff with CI, but I hadn't really kept abreast of it, and now I got to go think about it. Actually, it was thought provoking. So
here's something to think about to take home.
The takeaway.
What we could construct, and we'd have to work together, or somebody would have to do this work, but it's not impossible to construct a test using Cloud Foundry, right? Like we could take the CPI and write a test and have it just every time someone proposes a change to OpenStack, it like pulls it down and runs Cloud Foundry, runs the CPI suite against it, and like that way you could be like, hey, this is going to break the Cloud Foundry integration with OpenStack. Just FYI, maybe you shouldn't do that.
Actually, I had thoughts of like sharing this with the Bosch team tomorrow, or like in the near future, and like tomorrow or day after, and having a word with Dimitri on like what are the possible entry points and what kind of things they can actually test against, because it seems like a valid and interesting idea.
I mean, for the way Bosch works, it would be interesting to do. I mean, it's more about chaining the pipelines with Concourse or something, so that you have the right triggers, and as opposed to using Garrett for this review thing. I'm curious to see how it all evolves. I'm fascinated with this idea of like preemptive CI against upstream libraries, and I wonder if there's a way to abstract that. But going back to what you're just saying about trying to run Cloud Foundry as a part of the OpenStack CI, I think the reason, or one of the things that makes Cloud Foundry on OpenStack a little bit cumbersome sometimes is not that any one thing broke it. It's that those types of semantics slightly change in the different models, and then you have to like figure out what they've done, right? Like or how it's going to work, so you can get your the way Cloud Foundry works. It sort of has these AMIs, or we call them stem cells. So it's basically like a VM that has the embedded agents for Bosch when it's launched. And so then, like making those work, and then making all the APIs work, like that, from one deployment to another, like the other thing that will hurt sometimes is that the Bosch is it's not very gentle with APIs, and it'll request a lot of VMs, and it'll try to do a lot of stuff really fast, and it can actually overwhelm some of the deployments.
Yeah, the rate limits and stuff, or just physical. Yeah, but I think a simple test would be just to take, some simple CPI exercises of the OpenStack API and get that hooked up to a DevStack run, and then
Yeah,
just
no,
provide an informational +1 -1.
no doubt. I think that's interesting. So it's just like, hey, here's our basic vanilla OpenStack. We're going to call whatever kind of like def core or whatever, something makes sense. And then run it against a deployment and plus or minus on the Garrett.
Yeah, and especially coming because my team, that would be really cool. And I think you know where I work in IBM is right at the layer between inside Bluemix where the OpenStack ends and the Cloud Foundry begins. So it's like I'm the perfect person in a way to champion that. So
Well, I mean, one of the things that would, like, maybe we could collaborate with each other on that. Like,
yeah,
Pivotal and
exactly.
IBM could make that work, and then you have ability to do, or at least like a little bit more confidence, right? Like this new version of OpenStack is going to require this change to or whatever, like with the CPI.
Yeah. Just what we've done is we've lowered the barrier to providing that informational binary bit, so that it's like, why not do it?
So, you think that would take, if someone knew OpenStack and knew the CPI stuff, it's probably like
A couple hours.
yeah, like if you estimate it at like a week, you're sure it'd be pretty solid.
Yeah. Well, yeah, that's where I'm coming at. Like, I'm pretty new, so everything takes a couple hours. Yeah. So probably putting a week on that is much more reasonable. We'd also have to figure out where we're going to run it, like in terms of what infrastructure. And so, but yeah, it's an interesting idea. And of course, what I'm interested, there's the other side of it, right? There's the other direction, which is like, you take every release of Cloud Foundry, you take commits that are proposed on Cloud Foundry, and you run those against OpenStack, so that you can tell Cloud Foundry, hey, if you land this commit, you're gonna stop working on OpenStack. But that's a different direction, and harder for me to reason about how that information might transfer back and forth.
Yeah, absolutely. No, it gets really fascinating to do the thought experiment about how that all comes together.
Yeah.
Anyway, I appreciate your enthusiasm and your insight into these projects, and I'd love to see that collaboration happen, and I'd like to see both of these upstream having a bit more insight into each other.
Yeah. Yeah. Well, thanks for having me on the show. I really appreciate it.
Absolutely, it's just something to do on a Sunday night.
Yeah.
Well, I think everyone. I don't have any secrets, so if there was any secrets, or you're still awake for secrets, sorry. But I'm going to go. This week is going to be the Cloud Foundry Summit in Shanghai, so that should be fun for anyone who's over in China.
Awesome.
Shout out to I'm sure there's IBM people and Pivotal people. Oh, look, it's a Pivotal person. Waking up. Yunjin, you're on mute.
Yeah, actually, I'm the office, and our CEO in the house now, so we had a short meeting.
Oh, you're Rob Mees over in Pivotal Korea?
Right, and here's Melissa.
Well, hello.
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 So Yunjin, we're just mentioning Cloud Foundry Summit. You're going to go give a talk about the using Cloud Foundry to do backends for the games and the kind of stuff that you used to work on.
Yeah, actually, I try to explain about how the gaming industry can adopt Cloud Foundry. So most of the gaming is based on rely on HTTP protocols, and they are very good cloud adoption customers. So actually, there are not actual customer for Cloud Foundry in gaming industry now, but there will be. So I think there are many reasons they need to use the Cloud Foundry for their own developments and deploys kind of things. So yeah, it will be fun. And after this call, then I can share my slides to you.
Okay, I'll check out your slides. So unless anyone else is going to jump in, any more mystery people from Pivotal, then we'll call it a night, and I'll bid you adieu until next week. But thanks for coming, Spencer, and thanks for sharing all that stuff. It's actually fascinating.
Thanks.
Yeah, thanks. It's been a lot of fun. Nervous first time, but
Oh, no worries. It's no big
it's
deal.
chill group.
It's like no one watches anyway, so whatever.
Yeah, you never know. All right, I'll talk to you later.
All right, cheers.
Are you gonna? All right, one last. Are you gonna make it to Belgium for configuration management camp this year?
It's doubtful because I'll tell you after I stop the broadcast.
Okay.